Now we already know what the database looks like because we've logged into our server. We can see all of the tables and classes that are created when users authenticate with our application or when we've synced and watched contract addresses or events. But now we're going to take a look at creating custom classes, and we'll do the typical creating, retrieving, updating and deleting items from the database class. And we'll look at how we can do that manually and with code. I've got a simple application here that I've created, just basic boilerplate. I'll sign in and then we'll just be using the console here. There we go. We'll be writing our code in here. Let's go over to the documentation. On the left-hand side, we're going down to database now, and we will start with objects. Now in Moralis, everything that's stored inside of all of these tables and classes are objects. So when you want to create a new object inside of your table, you need to extend the Moralis object. This video here by Nicholas is very good at explaining how you can work with objects. I'd recommend that you would take a look through that, follow along with the instructions inside it. To give you some background information, when you are storing information inside of a Moralis database, the data is schemaless, which means that you don't need to specify specifically ahead of time what key value pairs will be included within each of the objects. You just simply set any information that you want to, and the backend will store it. Any fields that you want to add, you can add them, no problem. So in this example here, we're talking about an NFT game where the characters are going to be monsters. We scroll down. Whenever you're setting information into an object, just be aware of the following: that keys must be alphanumeric strings. Values can be strings, numbers, booleans, or even arrays and dictionaries. We would recommend that you name your classes with a capitalized first character, and that you name your keys in regular camel case with the first character will be in lowercase. To create a new subclass in your Moralis database, you just simply need to use the Moralis object extend method. An example would be down here: initialize a variable, and then you use Moralis object extend, and then you give the subclass a name. That will be the name of the table once it's created. Once you've created the new subclass, you then can create a new instance of that class. For example, here, monster equals a new instance of the legendary monster subclass that was initialized here. And alternatively, you can use typical backbone syntax like this. If we scroll down, the subclasses can contain a lot of information. For example, a more complex subclass of a Moralis object would look something like this example here. Inside of this, there are three different things that they have. There are instance methods, there are instance properties, and there are class methods. Just be aware of how the object is structured and how the information appears within that object. The method would be saved on the object and can be called. These instance properties will initialize immediately. And in this example, this is just adding a sound property to the particular monster. So monster.sound would now have this string raw attached to it. And in this example, the class method is used so you can spawn and create a new monster. So for example, down here, monster equals monster.spawn. So that's running this class method. And then it's passing in an attribute of 200, which would be the strength. And in this particular method, or this particular function, monster.set is going to add a new monster in the monster class, and it will have an attribute called strength, and it will be given the number of 200, which you can then save to the database. In this particular example, there's no command to save anything, so you could run this code, but nothing's actually going to be saved in the database. We'll have a look at saving objects in just a moment. Okay, if we move on down, you could even use new Moralis.object and pass a class name, and that will also create a single Moralis object with the class name that you've chosen. If you're familiar with ES6 syntax, then you would be able to use extends Moralis object like this, effectively creating a class-based component which passes the class name to the Moralis object constructor. You can then add the sound that was there before. You also then had the instance methods, you can add those, and then also the class methods you can add as static. However, just be aware when using the extends, the SDK is not automatically aware of your subclass, so you will just need to run Moralis object register subclass, similar to what we do on other platforms. And that's not just for Moralis.object, you can also use extends for the Moralis.user if you wish to. There's some examples of how to do that here. And in addition to queries, login and sign up will return the subclass with that custom user in this example. Okay, so that's the Moralis object. Now let's take a look at saving, retrieving, updating, and destroying objects in our database. So what I've done here is I've just separated the documentation from this mini app that we have, and we're going to go over to our database and just create a brand new subclass. In this example over here, the subclass would be called Monster. Let's copy this code, paste it over here. And there's a couple of things I'm going to do to change. I'm going to call this Creature instead of Monster. And I'm going to call the name of the table Creature as well. And Creature is with a capital C when you're creating a new subclass. And this lowercase creature will be a new instance of the creature object. There we go. And then we've got 3 attributes we're going to set here. I'm just going to set the strength to 512. I'll set the name to something different. Sirio. Can fly will set to false. You could create as many other attributes here as you want to, and they'll all appear in the database with separate field names. If you don't run save at this stage, then this just will not work. Nothing will get saved into the database. Also, this is saying monster.set. Well, of course, it's now creature.set, and it will be creature.save. The save method is thenable. If you want to run some additional logic, you can. So, for example, you will get the object back. In this example, it's just called monster. I'll leave that as it is. And we're going to alert that a new object was created with an object ID. But if it doesn't work, then we'll get an error, and we'll simply alert a string with the error.message. Let's see what that does. Oh, I must have created a typo somewhere. Let's go back and edit that because consta doesn't exist. New creature, probably saw that already. And there we go. New object created with the object ID. It's pretty small. You might not be able to see that. Now, we haven't awaited anything, so we're not going to receive the contents of the promise. But if we go back to the database and refresh, see a creature table. Here it is. Oh, there. And inside the creature table, if we just maximize the screen, we can see strength 512, owner name Sirio, can fly is false. The object ID was created automatically here, and you've also got the created at and the updated at, which is automatically generated as well. The ACL would be covered in more detail in the security section of this course, but it stands for Access Control List. And as standard, you get public read and write access to this new item, this new row in the class, and also the class itself will be publicly read and publicly written. So actually somebody could get access to the information in this database as standard unless you change the settings. We'll cover that in a later part of the course. Okay, let's go back to our code. So we've just created our first creature. You can run this code as many times as you like to create as many creatures as you like. Now, each time you run that, a new one will be added to the database. You don't need to worry about conflicts. For example, if you wanted to name something else with the name of Sirio and it had the same strength and all of the attributes were identical, because the object ID that Moralis creates for you will be unique. So there will be no collisions in your classes. Let's go back to the code and we'll try another example. And this time we're going to remove all of the thens and just run this. I've created some new code here. We're going to create a creature called Beric with strength 1024 with the can fly attribute set to true. And then we'll just put save. But if we go over to the database, refresh this, you'll see that you'll have the second one still in that database there. There's a couple of things here. The first thing is this creature subclass wasn't manually created by us. We didn't have to do that before we added data into the table. Moralis takes care of that automatically. If you try and extend and the subclass doesn't already exist, then it will create it once you save the information. If it is already there, it won't create a new one. It will just add to it. And those 4 columns we didn't need to create. They were automatically generated by Moralis. That will happen in every subclass that you create in your database. Let's go back to the documentation. That's pretty much what we've just explained here. This particular example runs things a slightly different way because what we did in our code was to run moralis.objectExtend and then ask for a new creature and then separately set the attributes to that creature. But you can pass it directly in as an object to the save method. And when saving items or saving objects, you can save nested objects. There's some information here about how you can do that. So in this example, the child is automatically created on the server just before saving the parent. But in some situations, you may want to prevent the default chain save. And if you want to do that, there's some examples of how here, essentially passing through this inside of the save method. As for cloud code context, well, this will make a bit more sense when we're more familiar with cloud code and triggers and how to use those. You can pass across a context dictionary that's accessible in the cloud code. You simply build your context dictionary as an object, and then you pass it through in the save method like this. It's typically an operation that doesn't need to be saved in the database, but that you want to trigger. And the application of this could be incredibly useful and will probably make more sense when you're more familiar with cloud code. And that is saving objects. So let's go and take a look at retrieving objects. I ran the code a few times just to get a couple of extra creatures inside of the database here so we can retrieve them from the front end. If we clear the console now. So as you can see, saving data to your server is super easy to do, and getting it out of the server is also just as easy. If we just copy this block of code here, now it's all publicly accessible because we haven't set any kind of access control list or class level permissions at all. So everything is publicly readable and writable, which is dangerous because it means somebody could come along and delete everything out of your table, which is why you need to look at the security side very carefully. And we'll cover that soon. But for now, let's just have a play with retrieving objects. But the code here, it checks to see whether the table exists. And in our case, it will, although it's not called monster, it's called creature. So we'll just change that. We'll create a new variable called query, which will be a new Moralis query, and it will query our creature variable. And then the next line we have here is query.get, and this looks like an object ID. So if we go over to the database, and if we double click on one of our object IDs here, let's copy this, go back to our app, paste that in there, and we may as well save what we get back into a variable. We'll call it result. And I'm not going to have any of this thenable stuff. I'll just leave it as that. Let's see what that does. And we'll look inside there. And we've got a promise result. We haven't awaited it, so this is why it hasn't resolved it immediately. But let me just go into the attributes here. And here we can see. So that object ID was for owner name Chris, strength 1025, can fly true. So if we now just add a bit more information to this original one, let's go and put the thens back in here. So we get our creature back here. Let's just tidy the code up. Okay, so that's tidied up. And if we have an error, then we'll just alert the error. So we'll just see what that does. And it passes us back that subclass of which inside that had our attributes. Now in here, we could actually run gets. So instead of just console logging, we could run something like that. So we'll go and grab strength, and if it fails, then we'll get an error. Return that, then there you go. And it returns the strength of 1025. And again, that's still searching this particular ID. We could change the query that we're looking on and get a different result. If we want to get all of the information, you could run something like this. In this case, we're just console logging all three attributes, owner name, strength, and can fly. So they're the three attributes that you can get. If we go back to our table, you'll notice that there are things like updated at, ACL, there are also created at an object ID, but you cannot use the get method for those for the simple fact that they are reserved values. You will need to fetch those in a different way, such as this. c.id, c.updated at, c.created at, and c.getACL and run it. That will probably return 0 because we don't have an ACL for any of these. It's just standard default public read and write. So that will probably return null. But if we run this, you can see that you get the object ID, get the two dates that we asked for, updated at, created at, and null for the ACL. So that's how you would fetch that information. Let's go back to the documentation and scroll down, and we'll clear the console. So if you need to get information from the Moralis object, you've got another method here called fetch that will allow you to get the latest data currently in the Moralis cloud. And there is another method here called isDataAvailable that you might want to utilize just to do some checking within your app. There you go. So that is creating and retrieving information directly from your database. Again, another video here for updating objects. Well worth taking a look at this. Updating an object is super simple. You could just set whatever attribute you like, and it will overwrite whatever you previously wrote. Always remember that if you don't save it, then it's not going to be stored. In this example, 5 attributes were set, then they were saved, of which with that object, more attributes were set. the attributes were changed here. CanFly was set to true instead of false, and energy was set to 1338 instead of 1337. So Moralis will automatically figure out that only 2 of those attributes were changed, and it doesn't worry about the other 3, keeps them as they were. So you'll notice in this example that this monster energy went from 1337 to 1338. That effectively incremented. Well, there are counter methods that you can use in the Moralis database. One is called increment and one is called decrement. If you just simply pass the field that needs to be incremented or decremented, it will go up by 1 each time it's called. Or you can pass a second argument with a different number, for example 5 or 10, and that would be the amount that it would increment or decrement. Arrays can be stored as a value inside of your object. So there are 3 operations that you can use for updating arrays. You have add unique, and remove. Add simply appends information to the array. If you try and add 2 of the same thing to the array, then this will allow you to do that. However, add unique will not. It will only add a single instance if the 2 are identical. And remove simply will remove all instances of the given object from the array. Now, these are 3 separate operations, so if you try and use all of them together before saving it, then it will not work. You'll need to have a separate save in between each one of these operations. So that's updating. Destroying objects is deleting an object. Again, this will typically require some sort of query to retrieve the object that you'd want to destroy first, but you simply have a destroy method. You can delete single fields by using the unset method. Just make sure that whenever you need to remove something from a field that you don't set it to null. That has some unexpected functionality. Excellent. The next one is relational data. Again, there's another video here by Nicholas that goes into a bit more detail. With relational data, you can create relations for one-to-one or one-to-many. And there's some examples here, or many-to-many relationships. And again, another couple of examples here. And these create relations between one class and another class inside of your database. We'll have a look at that in just a moment. And data types that you can use within a Moralis object will be any of the following. So I've just logged into my database, and here you can see that I've got a class called unit, and inside of here I've got a number of different objects. The objects have various attributes, but essentially what this is would be a database of soldiers or units for some kind of fighting game. And the attributes include things like the upkeep, so the cost of the unit, the movement points. This shows the number of spaces that the unit could move. It has a ranged attack. The first number would be the amount of damage it can inflict. The second number would be the amount of attacks that it does. HP would be the number of hit points for that unit. Abilities could affect its ability in some way. The name is the name. This user is the pointer. This is the user that created this particular unit. So that's relational data. We scroll across. We have a melee attack. Again, that's the amount of damage it can inflict and the number of times it will attack during its turn. The XP is the amount of points that it requires to level up in its evolution. And the accuracy is the probability that attack is successful. Now, this would be based on a game called West North. It's an old turn-based game that I used to play when I was younger. I just wanted to use it as an example to create this data. So in the database, I've got 34 units currently. So let's have a look at some examples of creating, retrieving, updating, and deleting these units. I've got a front end here, which just has a couple of buttons. One of them is going to be to get the units, which just goes to the database, queries them, pulls all the information in, and then displays them in HTML. And this button is just going to create a brand new unit. So every time I press this, I've got one down here. Every time I press this, I'll just do it a few times. It was Cathray was the last one. We've got now another 5 units here. So in the database, there's probably going to be a few more. I might have pressed that a few more times. I pressed it 6 times. So we now have 40 different units. Now the code that I created for this was just simple HTML. Again, it's got the WEB3, Moralis, jQuery, and Bootstrap libraries loaded. Got a basic Jumbotron with some body content. I've initialized Moralis and I have a login, log out function. Just checking whether a user is logged in, standard stuff. And this is where I've created a new class. There's a few things that I've done in here. I've extended the Moralis object and I've created a new class called unit. And in each instance of my unit, I've got some instance methods and some properties. And I've also got some class methods as well. But what I want the ability to do is to generate a random number, because I want all of those attributes to be generated for me. I want to generate a random name. I want to generate random attributes. I want to generate random abilities. So each time I run unit.create, I want to get a random name, random abilities, random hit point, movement points, experience, random upkeep, a random attack, and random accuracy. So that uses the instant methods and the class methods here. I have a function for creating a unit, which just simply runs unit.create, this class method here, and it saves it, so that will store it into the database. For the HTML render, I've got a getUnits function, and that will run a new Moralis query and find everything. There's no criteria, it's just going to find everything and return it. And for each unit that it finds, it will generate some HTML card and put it onto the front end. As we go down the app, I have actually created some additional functions such as add ability, add unique ability, and remove ability, so you can play around with the different updating array functionality. I've got an unset property function here as well, and a destroy, so we will be able to remove items from the database. And at the bottom of this app, there's a run query function. That's not important right now, but that just simply runs a new Moralis query, getting information where the HP is greater than 22 and where the XP is less than 41, and then finding it. And for each one of those results, we will return an object with this data and put it into this query array, and then we console log that. So if we looked in the console log of the application now, there should be an object already. And there it is. So these are all the items in the database that fulfill that particular query. So this button is running a create unit, so that will run the first function here. And that will run this class method to create a new unit and then set a whole bunch of different attributes and then save it to the database. So let's say we wanted to delete an item. We could go to this one here, for example, Catherine Door, and that will be the object ID we will delete. If we go back to the code, there is a function already for destroy object here, so we can actually just get this. So we query the unit table. We then go and get the item by the unit ID, and then we destroy it. So if I copy these lines, go back here, and we'll just replace this in here as a string rather than a variable, and then we run that. Now Catherine Door has gone. And that was the code that we used. We ran the query. We then searched for the particular object ID, which was the name of Catherine Door before, and then we run the destroy method. Another example, let's say we wanted to update the item. Let's say this item here, Kayla-tastic. Let's say we want to change the experience points to 45 from 40. We go back to the code. So we'll run a query. We'll get that object ID in there. And then with my unit, we will rerun these two lines. So my unit.set, and we want to set experience points, which is XP, to 45. And then we want to run save. I made a mistake. I tried to save a number as a string, and it needs to be a number. Let's see if this will allow. There we go. And if we refresh that and get the units again, Kayla-tastic now has experience points 45. Okay, so we've created, we've retrieved, we've updated, and we've deleted data. If we go to the database, the relational data is this one here. This is creating an attribute called user, where it's actually setting the Moralis user to the creation of the item. So if we click on that, that actually takes us over to the user table, and this particular user created that unit. Now that just showed a single user, but if you click on user, it will show all of the users that exist in the database at the moment. Back under the unit, these items were created by a different user. And that gives you a good introduction into objects. So go ahead now and have a look through all of these videos that appear here from Nicholas to fill in some of the gaps. And then we'll head on over to queries.